Hello everyone. Now I'm going to discuss about the second part of our talk, that is application of remote sensing and GIS in environmental monitoring and management. In the previous lecture, in the previous part, we have already discussed about the basics of remote sensing approach. In the second part of the talk, we are going to describe the methods and techniques of GIS and GPS. Okay, so before starting, first I am going to start with the term GIS. So GIS, the full form of GIS is Geographical Information System. And GIS is a computer-based system for capturing, storing, retrieving, analyzing, and displaying of the spatial data within a particular organization. This definition was given by Clark in 1986. So GIS deals with the spatial data. Spatial data means it's a kind of information related to the real world coordinate of any object. When we talk about any object on the Earth's surface, so what is its location, what is the latitude, longitude of the of that feature, and its real world coordinate is known as spatial data. So GIS deals with the spatial data sets. GIS deals with the capturing, storing, analyzing, and displaying of the spatial data within a particular organization. Okay, and GIS also provides the different capabilities to handle the georeference data sets. It is used for inputting the data sets. Then it can be used for data management. That includes the data storage and retrieval and manipulation and analysis of spatial data set. And we will have output in the form of some maps, some form of spatial maps that will have some locational information, that will have some spatial information about real world objects. So GIS is a, you can say it's a technique, it's an approach to deal with the spatial data, and that this spatial data is about the location of any feature, location of any Earth surface object on the real world coordinate. Okay, so GIS may have different names. We can have different names of the GIS, that is Geographical Information System, that is very commonly used name for the GIS. Then we can call it as a Geographical Information Science. Geoinformatics is maybe another term used for GIS. Then geomatics, spatial information system, geospatial systems, geospatial information engineering, or we can have another name of GIS is land information system. So these are the synonyms of GIS. We can use any of the terminology for GIS, but most widely used full form of GIS is Geographical Information System. Now moving to next slide. So GIS is having different components, different elements. As we know that GIS is a computer-based system, so there should be a hardware that includes good computing systems, the monitor, the system, and we have some software, some tools to process and analyze the data sets. We are having different types of data that can be gathered from different sources. It may have satellite images, it may have other data sources. And now we should have some methodology, we should have some procedures that can be applied on that data to retrieve some useful information that may be used for further application by different users in different organizations. So there are total 5 components of GIS, starting from the software part, the hardware part, the data, methodology or procedure, and the user, or you can call it as a people or any organization. So GIS is having total 5 components. By integrating all these 5 components, we can have geographical information system. So geographical information system is the abstraction of real world information. Okay, geographical information system is used to abstract real world information. So it may be called as an abstraction of the real world objects. Okay, so what is the meaning of abstracting the real world objects? As we know that the entire landscape over the Earth's surface, different real world objects are there. It may include different water bodies, then we have river, park, then we have different streets, roads, railway networks, railway lines, different land parcels are there. So the GIS is very much useful for abstracting the real world features, real world objects. That may include any of the feature, whatever you see around yourself. It may have any kind of tree, it may have any kind of water bodies, river, then it may have different houses, buildings, then streets, railway line, anything. anything, whatever you see around yourself is a real world object, and GIS is used to abstract. GIS is used to deal these real world objects to get some useful information, to retrieve some useful information that can be produced in terms of some maps, or you can say the output that we call it as a spatial map, that we call it as a map with latitude, longitude, scale, and other information. So GIS can do any thing, or GIS is used to solve any real world problem. Means it can be used for the identification of any feature, what is the location of any object. Then it can be used to see the trend, what is the changing pattern, what kind of ongoing changes over there. It can also be done by GIS. GIS helps us to find the optimum path, means it helps us to find out the relationship between different objects, different features on the Earth's surface. And it can be used for developing some model. It can be used for developing some best optimal model to solve any real world problem. So GIS helps us to identify, to locate, to see the trends, to analyze the pattern, and to find out the optimum path, and for development of a model to solve any real world problem. So GIS is having wider application. GIS is having very much usefulness in solving any real world problem. Okay, so GIS may be of different types depending on the need, depending on the requirement. We may have different types of GIS. That includes the desktop GIS, professional GIS, enterprise GIS, mobile GIS, internet GIS, embedded GIS, 4D GIS, and multimedia GIS. Okay, so GIS can be of different types, and we may have different types of GIS. We may have the option of using different types of GIS for particular application. Like desktop GIS can be used for personal use only. We can install any GIS system. We can install any GIS software in our personal computer or desktop to use the GIS for map making. Professional GIS can be used for commercial purpose. Enterprise GIS is having different application. Then we have mobile GIS, internet GIS. It is also known as web-based GIS, means the web-based services where we can display, we can publish our maps over the internet to be accessed by different users. That is known as internet GIS. 4D GIS, right now GIS can be used for creating 3D models of a city, for creating 3D view of any city or any urban area, or for visualizing any city in the 4-dimensional view. Multimedia GIS includes different types of data sources. It may have different images, maps, videos, and animations. GIS have different applications. GIS can be used to analyze different types of query. It can be used for spatial querying, single layer operation. It can be used for multiple layer operation. We can integrate multiple layers to analyze them. Then spatial modeling can be done using GIS technology. We can also analyze the surfaces. Network analysis can be done using GIS. GIS can be used to find out the optimum shortest path between the destination and origin in case of network. And point pattern analysis can be done using GIS. And grid analysis, like GIS can be used to analyze grid data, like raster data sets, what we generally call it as a satellite images. So GIS can do anything. GIS can do any type of query. It can do any type of operation using single thematic layer or multiple thematic layer. Thematic layers means different real world features. Like when we talk about the soil layer, we can have the vegetation layer, water layer, urban features are there, then the road network, streets are there. Multiple layers can be integrated and can be analyzed by GIS. Okay, GIS facilitates faster processing of the operation. It provides many real world problems with option of many scenarios. We can have the multiple options to solve any real world problem. It also helps us to make any decision, to take any decision, to be supported by any organized data. It can be used to integrate multiple data sources. Okay, we can also use GIS for displaying dynamic maps. Dynamic maps are a kind of display of spatial information in terms of maps. Then it is very much useful for handling spatial data. That is already discussed with you, that spatial data is a kind of data or the locational information about any object on the Earth surface. Okay, and it helps the it supports the digital format, means whatever the data we are having, it is in the digital format. So GIS can easily handle and manipulate the digital data sets, and it is a kind of data that may be used to produce a paper map and tables. Large quantities and types of data can be maintained and retrieved at a greater speed. So we can process any kind of spatial data with a faster rate, and we can easily manipulate and analyze any spatial data using GIS technology. And also we can have the option to manipulate the spatial data and corresponding attribute data. Means when we talk about the spatial data, it is having locational information and other characteristics, other information about that spatial feature is considered as attribute data or non-spatial data. So GIS can integrate both spatial and non-spatial data together to get information and to get different types of processing and analysis to solve any real world problem. Okay, GIS having multiple tasks. It may be used for inputting any data sources. Then we can go for the manipulation. We can manipulate any input data. That input data may be any spatial and non-spatial data sets. We can also manage different types of data sources. Then query and analysis can be done using GIS. GIS helps us to retrieve any solve problem. GIS helps us to find out question, answer to any question. Means query analysis can be done. If we are having a large volume of the data sets, large spatial data sets, we can perform query and analysis processing. It's a kind of it's a kind of task that can be done using GIS technology. And also finally, we can visualize our data sets in the form of some maps. That is very important. That is very important component of GIS. GIS helps us to display any kind of spatial information in the form of maps and tables and graphs. So GIS may have different tasks, starting from the inputting of the data, manipulation, management, query and analysis, and the visualization. Okay, so GIS is having a growing trend. Means starting from 1960s to till date, GIS is continuously growing. The use of GIS is continuously growing. There is a continuously growing trend in the GIS industry with the starting of the development of computers. And right now we are having very advanced computers. We are having very fast computing facilities. So GIS industry, or the utilization of GIS technology in different fields, in different applications, are now growing day by day. And now we are having very good computing facilities. We are having different types of GIS tools, GIS softwares that can be used to process and analyze any kind of spatial data sets to create different types of dynamic maps, different types of this information. And generally, when we talk about the real world problem, to make any decision, to solve any real world problem, or to develop a policy, or to develop any kind of real world applications of any spatial data sets. So GIS is very useful, and starting from the 1960s, it is continuously growing. The use of GIS is continuously growing day by day. So now moving to the next slide. So in the market, in the scientific community, in the society, we are having different types of GIS softwares are now available. Some of the softwares are proprietary softwares. For that, you need to pay some money. You have to purchase the license. But we are having different types of open source softwares. Open source GIS tools are available that can be used without any cost, can be available freely. So these are most popular GIS software packages are now available. eSeries, ArcGIS, MapInfo, Idrisi, Manifold, Intergraph, SmallWorld, GRASS, ERDAS Imagine, Ilvis, ERMapper, NV. These are very well-known, very popular GIS softwares. And GIS can be supported by other technologies like remote sensing, photogrammetry, GPS, the digital cartography. These are other emerging technologies that can support the GIS. Means whatever the GIS we are using, we can have remote sensing data sets. We are having the data from remote sensing technology. We have the data from photogrammetric technology. We are having photographs that can be used by the GIS systems that can be used for GIS softwares for further application. GPS data sets can also be used by the GIS technology. So these technologies can also support, these technologies effectively support the GIS system, okay, geographical information. That is very much useful. So we are having multiple data sources from the remote sensing, photogrammetry, GPS, digital cartography that supports the geographical information system for getting more detailed information. Now, moving to next slide, that is GPS, that is global positioning system. As we have already discussed that GIS deals with the spatial data, and these spatial data sets are a kind of locational information about any object with respect to real world coordinate. So in this way, the global positioning system, or in short, we call it as GPS, it's a kind of navigation system that can be used for timing and ranging. It's a accessory, okay, that can provide us the locational information in terms of latitude and longitude. Okay, so GPS can also be known as Navistar. Then it is known as Navistar navigation system, timing and ranging. GPS helps us to locate and identify the real world coordinate in terms of latitude and longitude of any feature of any object, any land parcel over the land surface. So GPS is very important for GIS. GPS is very important for geospatial technology because it helps us to validate our result with the ground truth information, with the ground truth data sets, then that we acquire, that we get from the field survey. Okay, so for the field surveying, for assessing the field data, we should have GPS that provides us the real world coordinate of any feature, any object in terms of latitude and longitude. Okay, so GIS and GPS both are very much useful, both work complementary, both work as a complementary technology with each other. And in terms of when we talk about the GPS, in GPS technology, time has been the limiting factor for a lot of science. So timely information, accurate information is very important when we talk about the real world coordinates. Okay, so for that, in GPS satellites, we use better accurate clocks for getting more precise information, for getting more precise location of any object. Okay, so GPS is the constellation or network of 24 satellites. These 24 satellites transmitting the signal to the GPS receiver on the ground, and these 24 satellites are well distributed in 6 orbital planes, 6 orbits, and each orbit is having 4 satellites. So there are 24 satellites, and these 24 satellites continuously transmits the signal to the GPS receivers on the ground. That helps us to determine the location, the direction, and the speed. Okay, so such kind of information is very much useful for geodetic control, in surveying, in engineering and mapping practices, and also the information gathered by the GPS receiver is used for cadastral surveying and cadastral mapping. So in this animation, you see how these GPS satellites revolves around the Earth in different orbital planes, and in each orbital plane there are at least 4 satellites, and there are total 6 orbital planes. So we are having 24 satellites revolving continuously around the Earth. So in GPS, having different components, GPS global positioning system is having various components. It is having satellites, atomic clocks, then microchips and calculators, radio beacons, and other transmission from the astro methods to modern methods and ground-based systems. The GPS is having various components. Okay, so GPS is controlled by Department of Space, United States of America. It's a project under the Department of Space that puts the satellite into the orbit. Okay, the first satellite of the GPS constellation, the first satellite of the GPS network, global positioning satellites, or the network of the global positioning satellites. Okay, the first satellite was launched in 1978, and the last satellite of the network, 24th satellite, was launched in mid-1990s. So currently, total 28 satellites in orbit, with more coming in the near future. These 28 satellites are continuously orbiting the Earth in different orbital planes to send the information, and that will be very much useful for getting the location and position of any object on the Earth surface. Okay, these GPS satellites are very high orbiting satellites. Okay, and after few years, one of the satellite will be replaced by the other satellite. Okay, so there are total 24 satellites in the orbital plane, and 4 satellites are in the backup mode. If suddenly one of the satellite is stopped working, so we can just at least at the time of the data, we can just replace the problematic satellite. So there is a large gap to the North Pole, so we are having not able to get detailed information, detailed locational information on the poles, especially North Pole. Okay, GPS is having different segments, different components. There are total 4 segments of the entire GPS network, that is having a space segment, control segment, user segment, and the ground segment. The space segment is the constellation of the satellites. The control segment is a kind of operation and monitoring, means the control segment controls and monitors the working of different GPS satellites. User segment means like on the ground, the GPS receivers are used by different users, different organizations for getting the information, and ground segment is the permanent civilian network that can be used for reference sites. So GPS is having 4 segments: space, control, user, and the ground segment. Okay, so the space segment consists all the 24 satellites. Currently we are having total 28 satellites. Out of 28 satellites, 4 satellites are in the spare mode, that are the backup satellites. Constellation design, it should be there, means each orbital plane is designed in such a way that at least 4 satellites in a view from any location on the ground at any time to allow the navigation. Okay, and the basic principle of GPS is to right time, right place, and getting information at any time and any place. Okay, so it is designed in such a way that at least 4 satellites continuously transmits the signal to the ground to locate its exact location on the Earth surface. So these are some characteristics of GPS satellites. Okay, it revolves in at the semi-major axis, having the radius around 26,600 kilometer. The orbital period is around 11 hours 58 minutes, means each GPS satellite completes orbit around Earth in every 11 hours 58 minutes. The orbital inclination is around 55 degrees. There are total 6 orbital planes. In each orbital plane there are 24, and there are 4 satellites. We are having 24 satellites. Each satellite is having approximate mass of around 815 kilogram, and the lifespan and the life cycle of each satellite is around 7.5 years. The transmission of the data rate, means the data rate transmission is around 50 beat per second, and each and every GPS satellite transmits the signal at L band frequency. Its frequency is having 2 parts, L1 and L2. L1 is having 1575.42 megahertz, and L2 is having 1227 megahertz. So these are some basic characteristics of GPS satellites that are revolving around the Earth in different orbital planes, that the information sent or transmitted by the GPS satellites on the ground is used to locate the information about any real world feature with respect to their exact location on the ground. So these are the location of different tracking and monitoring stations throughout the world. Okay, so we are having total 5 stations at different locations at Hawaii, then Colorado Spring, Ascension Island, Diego Garcia, and KwaZulu-Natal. Okay, these are some ground monitoring stations. From these ground monitoring stations, we can easily track and monitor the movement and the functioning of different satellites that can be used to monitor the health of the satellite, whether it is working proper or not. If some of the satellite is stopped working, then we can suddenly replace it by the backup satellite. So these 5 ground monitoring stations are having very important role to track and monitor the movement and the health and functioning of each GPS satellite in the network of the GPS. User segment, like as the user on the ground, we are the user, so we are having certain GPS receivers on the land. We can use it at any location on the earth surface. Okay, we are having extremely broad user community that can be used for navigation purpose. We use the GPS for navigation purpose, surveying purpose, geodynamics, geophysics, remote sensing studies like the study of troposphere and ionospheric concentration, time and frequency transfer. And the ground segment is a global networking, global system that is known as IGS global network. These IGS product reference frame is used for coordinates, orbit, and the earth rotation. And it also works on the development of regional networking. Okay, we are having different regional networking in Europe, Japan, USA for the densification of the reference frame to get more precise and improved real world information, real world coordinates of any object on the earth surface. So thank you very much. In this part of our talk, we have discussed about the basics of GIS and GPS. And now in the third and last part of the talk, we will see the application of GIS, remote sensing, and GPS. And combinedly, we call it as geospatial technology. So in the last part, the third part of the talk, we will describe different applications of RSGIS approach method in environmental monitoring and management. So thank you very much.